example time. All right, these are examples of using the properties of parallelograms to solve problems. So the first most important thing is that you figure out what kind of figure we're dealing with. In this one, we're dealing with a rhombus. And then you should have all the little properties in your head. The other thing I would do is read the instructions, find the measure of FGE, and somehow indicate in your picture what you're really going for. Because once you solve for X, you're going to want to just be done, but you're not going to be. All right, so in a rhombus, we know that all the sides are congruent. We know the diagonals are perpendicular. We know that diagonals bisect each other and all those kinds of things. But the one we want to use here is that in a rhombus, diagonals bisect the angles. And bisect means cut in half, which means that these two pieces have to be equal. So our equation would be 8x minus 49 equals 5x minus 7. And then you just solve that. So I'm going to do that quietly. All right, and you guys are all good at solving equations, so hopefully that was good. And you all got 14, just like I did. But what we really need to know is the measure of this angle here. Okay, so I'm going to plug 14 in for this right here. So I'm going to do 5 times 14 minus, which I did plus, minus 7 is 63. So right here is 63 degrees. And at this point, there's quite a few ways you could figure this out, but I'm going to do it the way I just saw, which is kind of look at this triangle right here. We learned way back when that the sum of the angles in a triangle is 180. So I'm going to do 63 plus 90, which is 153, and then do 180 minus 153. 27 degrees. So the measure of angle FGE is 27 degrees. All right, isn't this easier than the other paper? All right, let's look at another one. This one is a parallelogram, and we want the measure of angle PSR. So this is the angle we're looking for. In a parallelogram, the things we know about the angles are that opposite angles are congruent to each other, and that consecutive angles, or angles in a row, are supplementary. This is an example of consecutive angles, and supplementary means that they add up to 180. So we're going to add them up and set them equal to 180. Go ahead and press pause and solve that, and make sure you can solve equations well. All right, hopefully you're done solving, or you just pressed play and made sure you were right. And x is 18. There is no x in this angle. But like we said before, in a parallelogram, opposite angles are congruent. So I can plug the 18 in here and figure it out, and then that's going to be the same. So 7 times 18 minus 13 is 113 degrees, which means this is 113 degrees. All right, isn't this fun? All right, the next one says it's a rectangle, and we want the measure of QPT, so this angle right here. All right, so let's think about some things we know about rectangles. We know that in a rectangle, all the angles are 90 degrees. And we know that opposite angles are congruent. this one with this one, this one with this one. And consecutive angles are supplementary. But what we have here is none of that. But check these guys out. This angle that we know something about and this angle that we know something about are alternate interior angles. And alternate interior angles are congruent. So we're going to do 16x minus 17 equals 10x plus 1. All right, go ahead and solve. All right, hopefully when you finished, you got x equals 3, and we're going to plug that in. I'm going to plug it in right here because that's closest to what I'm looking for. So I'm going to do 16 times 3 minus 17, which is 31 degrees. Together, these two angles here have to add up to 90. So I'm going to do 90 minus 31 is 59. And that's the answer, 59 degrees. All right, we can fill in a bunch of other stuff in here, but at this point, this is good enough. So we're going to continue. So this problem, there's an actual issue. That is that I didn't tell you what it was. So if this was a problem given to you, you don't actually have enough information to solve it. But because I want us to, I'm going to tell you it's a parallelogram. All right, and then let's label our picture. It says that NS is 2x plus 7, and that SQ is 5x minus 23. Those are parts of the diagonal, so you should be thinking, what do I know about diagonals in parallelograms? And the only thing you know is that they bisect each other. Bisect means cut in half, so those two pieces have to be equal. Oh wait, I didn't even highlight what we were looking for. We're looking for the length of the whole thing. All right, so we're going to find x. All right, x is 10. You should be experts at solving equations. So you should either be pausing it, solving, checking your answer, or speed solving like I'm doing. All right, we're going to plug that 10 back in. So I'm going to write over these. 2 times 10 is 20. 20 plus 7 is 27. 5 times 10 is 50. 50 minus 23 is 27. So we did it right because they came out equal. And we want the length of the whole piece. So 27 plus 27 is 54. Not degrees, because we're talking about a length, not angles. 2 more. I hope they fit on our 10-minute video. If QRST is a square, find QS. So we want the length of this whole diagonal. Well, as soon as I highlight that, I see this whole thing here. And because it's a square, we know that this angle has to be 90 degrees. So I'm looking at a right triangle and I'm thinking, hey, since this is a square, this side also has to be 21. Now we have a right triangle and we know 2 sides. We're looking for the third side, which means we can use our good old buddy Pythagoras. We are looking for the hypotenuse, the longest side. So 21 squared plus 21 squared equals the longest side squared. $441 plus 441 equals c squared, 882. And we want to take the square root. And that equals approximately 29.7. And again, that's not degrees, it's centimeters. Because we're looking for a length, we're not looking for the degrees. Okay, hopefully this is making a little sense. Last, PQS